Let's take a look at this problem. We got f of x is equal to cube root of x plus 1, and g of x is equal to 4x squared minus x. And we want to find our first part. We want to find g, or the composition of g and f. Keep wanting to skip to step 1 of 0. Our first step is to rewrite this in the function notation. So this is g of f of 0. Now we're first going to focus on the inside here. So we want to find f of 0. F of 0. We're going to plug 0 in for the x, so I'm going to have the cube root of 0 plus 1, which is the cube root of 1, which gives us 1. And then second, I want to focus on this outer. Because we know now that f of 0 is equal to 1, so we're going to replace the f of 0 here with 1. So that becomes g of 1. So we'll go to our g of x, and everywhere we have an x, we'll put in 1. So I got 4 times 1 squared minus 1. 1 squared is 1, times 4 is 4, minus 1, which gives us 3 for our answer. B, we want to find the composition of f and g of negative 1. So we rewrite this as f of g of negative 1. And we'll first focus on the inner. So we want to find g of negative 1. Okay, so g of negative 1. We'll plug negative 1 in for the x. So I got 4 times negative 1 squared minus negative 1. Negative 1 squared is 1, times 4 is 4. Negative negative becomes a positive. So that gives us 5. And that's g of negative 1. So now we're going to focus on the outer here. I now know what g of negative 1 is equal to. It's equal to 5, so I can replace the g of negative 1 inside here with 5. So this becomes f of 5. And we're going to plug 5 in for the x. So I'm going to have the cube root of 5 plus 1, which is the cube root of 6. That doesn't break down any. 6 is 2 times 3, and our index is 3, so we're looking for a set of 3 of something, which we don't have. C. We want to find the composition of f and f of 2. And while I'm at it, let me go ahead and write down D. Composition of g and f of negative 3. Okay, so this we're going to rewrite as f of 2. Now we're going to focus on what's inside. So I'll focus on this first. So we're going to find f of 2. F of 2 will be the cube root. And we're plugging 2 in for the x. So we're going to have 2 plus 1, which gives us a cube root of 3. And that's what f of 2 is equal to. Then we want to focus on the outer. We now know what f of 2 is equal to. It's cube root of 3, so we're going to plug that in for the f of 2 here. So we're going to be finding f of the cube root of 3. Well, I go to my f of x, and where my x was, I'm going to plug in the cube root of 3. So we have the cube root of 3 plus 1. That's an interesting answer. And that's our answer. D. We want to find g of f of negative 3. So we're going to rewrite that as g of f of negative 3. Now we're first going to focus on what's inside, the inner. So we're going to find f of negative 3. So we got f of negative 3 equals, we're going to go to our f of x, replace the x with negative 3. So we'll have the cube root of negative 3 plus 1, which gives us the cube root of negative 2. Now that 3 is called your index. And whenever you have a negative number inside a radical where the index is odd, you can take the negative and just put it on the outside. You can't do that when your index is even. And we get negative cube root of 2. Now we're going to focus on the outer. We know f of negative 3 is equal to negative cube root of 2. So we're going to replace the f of negative 3 right here with negative cube root of 2. So we're going to be finding g of the negative cube root of 2. So I'm going to go to my g of x, and everywhere I have an x, I'll go ahead and put parentheses in. And in that side of the parentheses, I'll be plugging in negative cube root of 2. Well, when you square, a negative becomes positive. And there's a property that says if you got a radical and you're raising it to a power, then you can take that power and put it on the inside of the radical, like that. So that would be become 2 squared. I take this 2, put it inside with the 2 here. Here's a negative, negative, that becomes positive. Cube root of 2. So we got 4 cube root of 4 plus cube root of 2. There's different ways you could have wrote that answer. You could have also, once you handled the negatives, realized they both had a cube root of 2, and you could have factored that out. I don't think there's any particularly one correct method versus another in that. Okay, f of x is equal to cube root of x plus 1. And g of x is equal to 4x squared minus x. Okay, we're ready for E. Composition of f of g of 1/2 which we rewrite as f of g of 1/2 So we're going to start with the inner first. It's g of 1/2. Let's find that. G of 1/2. We're going to go to our g of x, replace our x with parentheses, and then we'll plug in the 1/2. So I got 1/2 here, 1/2 here. Now 1/2 squared is 1/4 minus 1/2. Those 4's cancel. We got 1 minus 1/2. And I could use a mixed number rule here. I could take 1 times 2 is 2 plus a negative 1 is 1, so it gives us 1/2, or I could get a common denominator. But either way, g of 1/2 is equal to 1/2. So now we're going to focus on the outer. We know g of 1/2 is equal to 1/2, so I'm going to replace the g of 1/2 right here with 1/2. So we're going to be finding f of 1/2. Okay, so we're going to have the cube root And I'm going to put 1/2 in for the x. So 1/2 plus 1, which is the cube root of 1 times 2 is 2 plus 1 is 3, so it gives us 3/2. Now, as a general rule, we don't want a fraction inside of a radical ever. So I can split this up. I can put a cube root around top and cube root around the bottom. We got a property that allows that. Well, that creates another issue. We can't have a radical in the denominator. Well, this is rationalizing radicals, if you remember that. Since we got our index is 3 and we got 1, 2 here, what I need is 2 more 2's. Since my index is 3, that means I need 3 2's. So I got 1 here, I needed 2 more. It's all driven based upon your index. And whatever I multiply by the denominator, I have to multiply by the numerator, the number up on top. Which gives us the cube root. 2 times 2 is 4, times 3 is 12. And down below, since my index is 3 and I got 3 2's, that simply becomes a 2. And that's our answer. And F. F is composition of F and F of -2. Which I'm going to rewrite as F of -2. And we're first focused on the inner. F of -2. So we're going to plug -2 in for our x. So we've got the cube root of -2 plus 1, which is the cube root of -1. Now, -1 I could rewrite as -1 times -1 times -1. Because -1 times -1 is +1 times another -1 is -1. And our index is 3, the number in the slot here. That tells us we need 3 of something. We got 3 -1, so it'll come out as a single -1. I've kind of blurred that into the previous part. Okay, so now we know f of -2 is equal to -1. So now we're going to focus on this outer. We know f of -2 is equal to -1, so we'll replace the f of -2 here with -1. So what we're going to be finding is f of -1. And f of x is cube root. And we'll replace the x here with -1. So that's -1 plus 1. That gives us cube root of 0, which gives us 0. And that's our answer.